couple notes that I would like to include on the top of your paper. Remember, this is your model for linear. Your M represents your slope. And when we're talking about linear, our slope can only be adding or subtracting. So there's your signs to put in there. Your B is your starting point, or your y-intercept. Now when we're talking about exponentials, your model is going to look a little bit different. We've talked about the pattern being next to the x, just like it is for linear. That pattern is right next to the x. It's the same thing over here. So now A is our starting point, and B is our pattern. And in exponential, it's always what you are multiplying by, and it is next to the x. You will be creating models or writing equations for linear functions and exponential functions on the OST. You know how to do it. You know how to grab information and put those numbers in the right spot. Which is why we're going to practice today. Okay. The relationship between the distance driven and total cost when taxi driver charges $2.50 for the first mile and $1.50 for each additional mile. So that each additional mile, that should make you think of slope, or that word curve that we've used before. That should drive you to linear. This is going to be a linear model. So you're going to create the linear model and just make it a fill in the blank. And now we're just going to fill those numbers in. That $1.50 for each additional mile needs to be your slope. That needs to be by the x. So that's where we're going to fill in $1.50 here. And then that $2.50 for the first mile, that's your starting amount, that's your basic fee, that's where you start. And that's a positive $2.50. Don't lose points for forgetting that plus sign. Sometimes you start at a positive amount, sometimes you start at a negative amount. Make sure you have a plus and a minus sign there.
Yeah, guys, these are the same these are on your paper, you just don't have the blanks.
Alright, we'll keep going. Now we're looking at a relationship between the number of bacteria and time the culture of 6,000 bacteria is reduced by 50% every day. So when you see that percent, maybe we should have put that back over here with exponential. Anytime you're dealing with a percent change, that's going to be an exponential model. So like with this one, we've got a 50% change. What's 50%? We're changing 50%. So here's our exponential model. We're going to go ahead and create our y equals blank times. You've got to have that x there. Here's another thing that's really, really important. That reduced by 50% or reduced by half each day. So here's our starting value, and then here's what we're multiplying by or what we're changing by. If we're reducing by 50%, what are we reducing by? How else can we call that 50%? That is, it's half, it's 0.5, yeah. So if you want to put 0.5 in there or 1/2, then go ahead and do that. What's our starting value? It's 6,000. Right now we're not talking about how many days have gone by, but that will be your x value. We're just creating the model. Okay, so now we're talking about the altitude of the hot air balloon and time when the hot air balloon takes off. And then it's rising 120 feet every single minute. Linear exponential. We are rising 120 feet every minute. We're not multiplying by anything, we are adding. We're adding 120 feet. So that's our linear model. y equals blank, x blank. We just have to fill in those blanks. We know that the hot air balloon is taking off at 5,500 feet, so that's our starting amount. Just have to be careful with which space we're plugging that into. Here's our starting value. And we are rising 120 feet. So 120 feet goes right here. Positive 120, so we're going up 120 feet every single minute. Moving right along. Our cell rents a moving truck. The rental company charges $40 a day, and then 50 cents per mile. So here's that per mile, that rate, which hopefully makes you think slow. So let's go ahead and I see that we are starting with $40. And we're not multiplying by anything. We are adding 50 cents per mile. So let's go ahead and we've identified this as linear since we're adding. And let's create our equation first. Y equals blank, x blank. Okay, so our starting value is going to be $40. That's where we're starting. That's how much that rental company is going to charge a day. Then on top of that, we're adding 50 cents per mile. Make sure you get your decimal in there. There's our 50 cents for every mile that goes by. Now we have an additional question that goes along with this. How much is it going to cost to rent the truck if Marcel drives 220 miles? Okay, so now we have an additional number here. That's going to go in for your x value. So that number is going to go right here. Talked about this being a couple different ways that you can work this problem. You can use Desmos to pull up your table of values and put 220 in for your x. You also can just plug 220 in for your x here and do this equation in Desmos. How much money is this going to cost after how much? $150. Good. Good. So if you were using a table of values in Desmos, you'd be plugging 220 in for x, and the number you would get out is 150. Okay, now we're studying a population. It feels like usually when we study a population or we're looking at a population, it tends to be exponential. At the beginning of the study, you find a lake has 1,000 fish. The population doubles every year. So I like to make notes as I'm going. We are at the beginning of the study, the lake has 1,000 fish. So this is definitely what we are starting with. And then we've got this word here, doubles. Doubles means that we're multiplying by what? Yeah, we're multiplying by 2. So we know that we're going to be using an exponential model. Let's go ahead and create our equation. Y equals blank times blank to the x power. Always turn it into a fill in the blank. We know that our starting value is 1,000. Our starting value goes right out front. And we are multiplying, or we're doubling every single year. So we've got 2 inside the parentheses. We're multiplying by 2 every year. The other thing I'm noticing is when it says every year, I know that this x value, that is going to represent the years. So now I'm being asked, okay, how many fish on a lake after 6 years? So we're going to use that exact same model. And instead of that just being an x, we're going to fill in 6. This goes into Desmos. When 6 years has gone by, how many total fish are going to be in the lake? Yeah.
I mean, 6.
You're right, 6,400 fish. 6,400. Thanks for staying with me. Okay, so this is a multiple choice. Yeah, did I write 1,000?
Oh, it's 64,000.
Oh, I'm sorry.
You just missed the zero.
I just missed the zero. Sorry. There we go. Thank you. Thanks for catching that. Thank you very much. Okay. All right, so now we have a table that shows us the cost of renting a bicycle by the hour, including a deposit. So we've got hours here on the left-hand side. These are our X values. Cost in dollars, these are our Y values. If hours is H, we're graphed on the horizontal axis, and cost C was graphed on the vertical axis. What would be the equation of a line that fits the data? Okay, guys, so there's a lot going on here, and I feel like this can be kind of a confusing one. What I did for mine is I looked at the pattern, and I went over here and I tried to figure out a starting value and where a starting value would be here. We've got 4 different equations. I looked at this pattern. How did we get from 15 to 30 and 30 to 45? We added 15. We are adding 15. Now we have to be a little bit careful. We're not going up by ones. We're actually adding 3 over here. So we have to be careful with that skill. What I can do right now is look at the slope. I can find my slope. Remember, slope is your change in your Y values over your change in your X values. So how am I going from 15 to 30 and 30 to 45? I am changing by 15. How am I going from 2 to 5 and 5 to 8? I'm changing by 3. So again, this is your change in Y over the change in X. Well, I also know what 15 divided by 3 is. 15 divided by 3 is 5. So my M is going to be 5. Right now I can get rid of an option. I can get rid of this one. That slope is 1/5. I need my slope to be 5. So I'm feeling pretty good that my other slopes are 5. Now we just have to find our starting value. We can't just look at the very first number here. We actually have to go back. So if we were looking at what we were going up by, I'd like to add a 0 and a 1 here. I need to find the Y value when my X value is 0. So really, we've got a 3 and a 4 in here. 2, 3, 4, 5, 6, 7, 8. So I need to go back and figure out how much I'm moving every single hour. I was actually starting at 5. And then my pattern would continue. This was 5, and this was 10, and then I would continue to go up by 5s every single hour.
So plus 5.
So I'm looking at what my starting value would be. My V is positive 5. You have to go back to where your X value is 0, not just the first number in the column. And that's the trickiest part about these problems. So now I know my slope is 5 and my starting value is 5. Y is equal to 5x plus 5. I know I'm using different letters over here, but I found my model. Okay, I feel like that was probably one of the trickier ones. Okay, I've got an exponential growth. Already I know this is going to be exponential. So y is equal to blank times blank to the x power. I also know that this is growth. So I need this number to be bigger than 1, since it's a growth. Okay, since it's exponential, we need to be multiplying. Those are some other things that I know since I'm dealing with exponential. So that's something else that I would jot down. Let's start to look at our examples here. A water tank is filled at a rate of 2 gallons per minute. So adding 2 gallons a minute makes me think of a slope or linear. I'm going to cross off that option. A vine grows 6 inches every single week. Again, that's the same idea. We're adding 6 every week. That's linear. A species of flies doubles. Ooh, doubles makes me think of multiplying by 2. And 2 is bigger than 1. So I'm feeling pretty good about number 3. A car increases its distance from a garage as it travels at a constant speed. Oh, so constant is definitely linear. All right, I'm going back to number 3. Those are just options you have to match that are an exponential model. You're not given any specifics, you just have to find the one that's an exponential model. Okay, thanks for hanging in there. Milton has his money invested in a stock portfolio. We've got the value v of x of his portfolio can be modeled by the following function. Don't get lost in all the words and all the letters. Don't get lost with all that. X is the number of years since he made his investment. Which statement describes the rate of change of the value of his portfolio? Okay, so we're using the model that's given to us. We just have to find the rate of change. And all of our answers are going to be written as a percent. So the only number that we care about is this one right here, this 0.78. What we're going to do is we're going to turn 0.78, we're going to go back and get rid of that decimal. Let's turn that back into a percent. So we're going to move that decimal twice and turn this into 78%. How far away is 78% from 100? How far? Yeah. So we're looking at the distance from 100. We're just going to subtract that from 100 to get 22, and that's what we have here. Make sure that you're choosing the decreases by 22% because this decimal, that 0.78, it's smaller than 1. So we know that this is going to be a decreases or a reducing. Okay, flip your paper over. We've got just 4 quick problems to work with. These were not great when we did these with our quadratics unit. So we're going to hit them pretty hard. You guys are definitely going to see models, linear and exponential models. So we've got to be able to pull numbers out and put them into equations. We first have to decide linear or exponential. We're joining a racquetball club. You have to pay a membership fee of $35.50 to join, plus $12.25 per month. So this plus $12.25 per month should make you think linear, and that is the slope. So here's definitely linear. Fill in the blanks. Our slope is $12.25 a month. Here's your per month. And then your starting value or your basic rate is $35.50 to join. Positive $35.50. Okay, we have a population of squirrels, and we are diminishing by 2% each year. I see a percent, so that's definitely telling me exponential. The other word I see here is diminishing, so I know that this is going down. The population first recorded the park had 281 squirrels. Okay, starting value and what we're multiplying by. Gotta have that x up there to make it an exponential. Have to have that x. Okay, I know how many squirrels I started with. We're starting with 281. Now remember, the number that goes in here can't be a percent. It has to be the decimal form of the percent. How to change that percent to a decimal. So here's my 2%. I need to move that decimal back 1 and 2 places. So that turns into 0.02. And since I'm going down, remember, we have to subtract that from 1. We're looking at the distance from 100, so we have to subtract that away from our 1. All right, a couple more. We have children in Delaware County. Our population is rapidly increasing. The county released their 2017 census. The number of children in the county were 12,480, and it was expected to double each year. So here is what we started with, doubling each year. It's multiplying by 2. So definitely exponential since we're multiplying here. Y is equal to. Gotta have that x up there to make it an exponential. Our starting value is 12,480. And we are doubling each year, so we're multiplying by 2. Okay, last one. The heat in the school went out. Temperature is slowly decreasing. Okay, temperature is going down. At noon it was 73 degrees, and each hour it's getting 2 degrees cooler. Okay, so we are going down 2 degrees. So I like to write that -2. We're not multiplying by anything. Remember, linear is either adding or subtracting. So this is definitely a linear model. Make it a fill in your blank. We are starting at 73 degrees. We're starting at a positive 73, and then from that 73 degrees, we are going down 2 degrees. So the trickiest thing, and what you have to remember, is to get that negative sign in there, because we're going down from the 73, we're not going up. Sometimes a negative slope is a little bit harder to pick out from a model or from a description than the positive slopes are. Okay, at this point, we are just finishing or working on day 7. After you're done with your day 7, make sure that you're giving us your score, sending us an email, letting us know what you got so we can include that score. And then you can go back and work on some of those other campus quizzes that you were talking about and maybe didn't have a chance to finish.